now we should start with the 12th, with the 30th exercise. So I feel you. I'm banging my head against my deck with today's problem. Holy shit. Okay. You're worrying me. Oh god. So 13. Your ferry can make it safely to a nearby airport. Sorry, to a nearby port, not an airport. But it won't get much further. When you call to book another ship, you discover that no ships embark from that port to your vacation island. You'll need to get from the port to the nearest airport. Fortunately, a shuttle bus service. Oh no, this is a scheduling problem. I can already smell it, and I understand why you're stuck. Oh god. Fortunately, a shuttle bus service is available to bring you from the seaport to the airport. Each bus has an ID number that also indicates how often the bus leaves for the airport. Bus schedules are defined based on a timestamp that measures the number of minutes since some fixed reference point in the past. At timestamp 0, every bus simultaneously departed from the seaport. After that, each bus travels to the airport, then various other locations, and finally returns to the seaport to repeat its journey forever. The time this loop takes a particular bus is also its ID number. So the bus with ID 5 departs from the seaport at timestamps 0, 5, 10, 15, and so on. The bus with ID 11 departs at 0, 11, 22, 33, and so on. If you are there when the bus departs, you can ride that bus to the airport. Your nodes, your puzzle input, consists of 2 lines. The first line is your estimate of the earliest timestamp you could depart on a bus. The second line lists the bus IDs that are in service according to the shuttle company. Entries that show X must be out of service, so you decide to ignore them. Until we get to part 2, I suspect. To save time once you arrive, your goal is to figure out the earliest bus that you can take to the airport. There will be exactly one such bus. So for example, suppose you have the following nodes. Here, the earliest timestamp you could depart is 9:39. And the bus IDs in service are 7, 13, 59, 31, and 19. Near timestamp 9:39, these bus IDs depart at the times marked with D. So 9:39 is our target. The idea is that we cannot get there earlier, so the first one right after is our target. The earliest bus you could take is bus with ID 59. It doesn't depart until timestamp 9:44, so you would need to wait 5 minutes before it departs. Multiplying the bus ID by the number of minutes you need to wait gives 295. Okay, so this seems easy. Oof. No optimization yet. So what is the idea of the earliest bus that you can take to the airport multiplied by the number of minutes you need to wait for the bus? Okay. This doesn't seem too evil, so day 13, new, save, buses.txt, day 13, const data equals at. What happens if I do a double at? And no. Oh, this works. So dumb though. Buses, please, Sublime. So we have our data. Then oh, I didn't paste. Okay. Like I think this can be solved easily, mathematically speaking. less famous words, but hey. So what we can do is var it equals std mem tokenize as usual data on a new line, and then we do var I don't know, available. I don't know. You know what? Let's say me. This is me when I can arrive. So me is gonna be try std.fmt parse int is a usize from it.next question mark base 10. So this is the first line, and the second line is going to be the buses. So var buses is it.next. We know it has to be there, and we need to tokenize this again. So std.mem. Actually, you know what? I could do tokenize on also the comma. You know what? Yes, let's tokenize on new line and a comma. And at this point, I don't need to do a second tokenize because I'll split on the new line and then I'll start splitting on the commas, and that would work. So, so we have me, and then while it.next we have a bus. You can pass a type as a function argument. Oh yes, and that's one of the most amazing things about Zig. Flounder, a HSR client, did you per in SSI get to you? So okay, let me answer two questions one at a time. For types as values, I recommend you take a look at ziglegend.org. Here's the introduction. It explains also what comp time is. So ziglegend.org here. If you want something else, there's also a blog post they wrote. Blog. What is Zig's comp time? About the fancy things that you can do with comp time in Zig. Oh god, why did everything corrupt this way? Sorry. I sent one crappy message. And so there's also interesting too if you want to learn more about how Zig comp time works. Pretty neat. Flounder, to answer your question, I'm doing the AOC stuff now, and I momentarily failed the chat thing. So the point is, I think I want a chat that is in the terminal, but also that shows emotes. And IRSSI doesn't show emotes. And to get to the point where I can show emotes in here, I basically want to make my own client. I could probably hack this stuff on top of IRSSI, but I don't want to deal with the weirdness of the system. So what I was looking for is just a simple terminal UI library written in Zig, and then from there do my own magic from scratch. There is something similar, like there is a, I fear this might be useful later, so I won't delete it, but like Twitch, people don't say IRSA. I don't know. I think that the reasoning that I'm doing in my mind is that IRC, like if I just say IRC like too close to what IRC is, then you won't know if I'm talking about like the protocol or the client. Maybe the context kind of makes it clear, but you know, I'm not sure. I'm not sure. I'll just say IRSSI. I don't know. Twitch terminal chat. So for example, somebody has made something like this. The problem is, so it requires Node, and it requires Docker to run a local API server. So, like, this is a no. Like, this is a no for me. So I just want a single executable written in Zig, which is attainable. The problem is the TUI library that Jesrad wrote works on Linux but doesn't work on macOS. And I tried to add, there's a couple of definitions or a couple of structs that are missing from the Darwin OS layer. I tried to add them, but then I encountered a weird crash that I've seen other times with executables compiled for Mac. And that's a Zig thing, like that's a Zig compiler thing. So I gave up for a moment. I need somebody to unblock me on this. There's a Stack Overflow happening somehow in a situation where it doesn't make sense for the Stack Overflow to happen. So if somebody solves that, then I get a decent terminal UI library in Zig, and then I'll be able to do my client. Anyway, now I'm back to the advent of code because of that. So sorry, and end of the parentheses. Let's parse these freaking buses. So we get a bus. If std mem dot equal u8 b and x, if it's just an x, we continue. We skip everything. If it's not just an x, it means it's a number, so we can get the number. Var n equals try std fmt parseint usize b base 10. Okay, so now we have the number. Now, what do we do with these numbers? We know me, at what time I arrive. We want to find the mean after me, usize, and mean after me, I don't know, what do we set it to? What do we set it to? We should give it like an initial value that is like super high. I mean, we could also do an optional, but what I would like to do basically is the ability of saying something like var mean after is, I don't know, compute mean after me, or mean after, and then we pass in n and me. And then I can do is if mean after is lower than mean after me, then we swap them, right? Mean after me equals mean after. That's the idea. The problem is we want to give this an initial value that is high enough. Again, I could do optionals and say if this is empty, then just put whatever value we have. But here's what I'm gonna do. I'm gonna cheat, and I'm gonna say it's me 100 times me, and I'll assume that nobody is, or maybe 100 times is too much, but like I'll do 50 times me, and I'll assume that I would probably find a better answer than 50 times me. Probably. So let's hope that's the case. And I mean, given the number of buses, you can see they're kind of small, so this is possible. It's kind of possible. Another smart way is something like divisibility or something. I don't know. In any case, that's one thing. The other thing is that we need to keep track of the bus name, the bus ID. So bus ID equals undefined. And that's also a usize. Are you sure you can cooperate with 49 under use? Ah, that's a good question. I don't know. The synergy would be amazing though. Although, you know, but then when I get in these situations, then you need to make 50 people understand what I did wrong. So there's also downsides. And then they basically all 50 become useless. So there's also that. So mean after me, blah, blah, blah. All horrible variable names, by the way, that I found. But at least for this. Candidate. Let's call this candidate. So how do we do this candidate? One thing that we can do, I think, is using rem. So let me think about this. So the straight way of doing this would be to keep multiplying the same number until you surpass this number here, and then you stop. But if we use modulo stuff, we should be able to obtain the delta more quickly. And like the idea is it shouldn't matter the speed, because this example is short enough that performance should not really matter. But for some reason, I am tempted to explore this mathy part of the problem. So I kind of want to try. I know this might make me fail, but I want to try. So oh boy, no, come on, should not be that bad. So what we do is I want the remainder of me divided by n do I want the remainder? No. I think I want the mod. This gives me a reminder that I know is always positive. And so I need to do so what do I need to do? What if there is a reminder? So let's say that I can arrive at minute 6. I can arrive at minute 6. And the bus arrives at minutes 5 and 10. 6 modulo 5 gives 1. Which is 5 minus the remainder. And that's the weight, but only if it's not 0. If it's 0, we don't need to do this. So we have the candidate, and here's what we can do. Here's what you can do. Const mod, mod. Calculate the mod. And then we do const candidate is if mod equals 0, it's 0. Else it's n minus mod. And that's our candidate. And then bus ID is this bus ID. Bus ID is n. There is no way this can go wrong. I see no possible way for this to be wrong or go wrong. So gonna be nice first try, I'm sure. Yeah, I'm going for the web scale solution, absolutely. So wait is gonna be mine after me. Bus is gonna be B. Res is gonna be is it wait times bus? Bus ID by the number of minutes. Yes. B times mean after me. Honestly, there is generally no way for this to go wrong. Expected token found continue. Yes, good point. And user undeclared identifier B. Ooh, right, because that's bus ID. Wait 10, bus 37. Right answer. So the web scale solution actually works, and I don't know, math. Okay, now we're gonna be hit with the optimization thing. Please no. The shuttle company is running a contest. 1 gold coin for anyone that can find the earliest timestamp such that the first bus ID, the parts at that time, and each subsequent listed bus ID, the parts at that subsequent minute. The first line in your input is no longer relevant. So for example, suppose you have the same list of buses as above, and X in the schedule means there are no constraints on what bus IDs must depart at that time. This means that you're looking for the earliest timestamp called T, such that bus ID 7 departs at timestamp T. Bus ID 13 departs 1 minute after timestamp T. So that's already not the case, right? Wait. Oh, but wait, if you do it enough times at one point, you will get that. There are no requirements or restrictions on departments at 2 minutes after timestamp T. Okay, this is confusing me. I don't have enough brain juice anymore. God damn it. There are no requirements or restrictions on departments at 2 or 3 minutes after timestamp T. Bus 59 departs 4 minutes after timestamp T. There are no requirements or restriction on departures at minutes 5. Again. Bus ID 31 departs 6 minutes after timestamp T. Bus ID 19 departs 7 minutes after timestamp T. The only bus departures that matter are the listed bus IDs at the specific offsets from T. Those bus IDs can depart at other times. And other bus IDs can depart at those. Oh no, I need more brain juice. Oh god. Oh god. For example, in the list above, because bus ID 19 must depart 7 minutes after the timestamp at which bus ID 7 departs, bus ID 7 will also be departing with bus ID 19 at 7 minutes after timestamp T. What? In this example, the early timestamp at which this occurs is 10 blah blah blah. In the above example, timestamp 7 parts at times the parts at timestamp something something 7 minutes after t. That is fine. This is fine. The only requirement on that minute is that bus ID 19 departs then, and it does. There are some other examples. The earliest timestamp that matches the least 17, 30, 19 is 34, 17. 67, 7, 59, 61, first occurs timestamp something, 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 something. However, with so many buses in your list, surely the accurate timestamp will be larger than a lot. What is the other timestamp such as that all the listed bus IDs depart at offsets matching their positions in the list? Okay, so the idea is okay. Maybe I can do it without dying. Maybe. Part 1, part 2. I wish I had Zig formatting. Why is this not working? What if I disable LSP? Disable language server globally for Zig. No! Come on! Yes. Disable it globally. Then why is this annoying me still? God damn it. Wait, could this be coming from something else? No, this is the LSP. I know it. Yeah, look at this, ZLS. In any case. Okay, so what we want to do here is, we don't care about anymore. So we burn the first line. And then we start getting buses. So now I think what we need to do is we need all the buses. We totally need all the buses. So var, how many of those do we have here? Annoying. Var buses is I want to make it an array of optional usize. Does it make sense? I think yes, it makes sense. How many of those are there? I don't know. You know what? It's easy. Let's put like 50 slots, and then I'll find soon what the right thing is. And they all start at null. Well, does it matter? No, it doesn't matter. So it's an array of 50 optional usize, starts undefined, and then for each slot, you grab a pointer to the slot. And what do? We do should we iterate this or should we iterate the other thing? I think we should iterate the other thing. You know what? Here's what I'm gonna do. I don't want to make this. I could make this dynamic, but I'm so lazy here's what I'm gonna do. I'm gonna replace every single comma with a new line. And then we're gonna count the lines. It's 78. Okay. Ah, you didn't see anything. It's 78. So we have 78 of these things, and for each of those, we say b dot star is try. Well, it's not actually try. If it's an X, we do one thing. B dot star is null. Otherwise, we try to parse a number. See what people are saying. Rather spend it on other useless endeavors. I don't like. Let's see, what am I missing? I don't like algorithmic competitive programming. Different challenges, but the competitive side is boring. Well, I agree. Competitive side is super boring. I mean, like being able to solve stuff fast, right? Hopefully first try. It's definitely a proof of being good. It can help to some degree in real life, but over optimizing for that doesn't make you really effective. Like programming, how often is programming fast core to what you're doing? As in, there is a big difference in taking 5 minutes versus 15 minutes in solving a problem, a programming problem. I don't know. Maybe in some situations it can make a difference, but I think not often. And I think the least explored part of software engineering is actually the inverse. Since you have a lot of time normally in your hands, making something good that is robust, that is usable, I think that's where the real challenge is, at least in the modern world. I don't know, maybe in the future we're gonna all be in spaceships and like air is escaping from the airlock and you need to code a solution quickly enough, so otherwise you're gonna run out of air. In that case, holy shit, being able to do this fast it's important, I guess. But anyway, so if it has, we set it to null. Otherwise, we std fmt parse int. Oh god. So okay. So now ZLS really died, but did I gain anything? I haven't regained Zig FMT. Oh my god. Zig says syntax. It's Zig already. Format file. Oh yeah, right. I have the. Oh god. Okay. So you know what? Enable the language server. And okay, well, I guess we're back in business. So parse int usize Suzy. Oh no, why is the autocomplete not working? Sublime. Why is the tab now not moving forward? I hate this stuff. Oh man. So B radix 10. Okay, so we either have nothing or a time. Yeah, Sublime Best IDE. Well, I don't use it as an IDE. I use it just as a normal editor. But LSP is introducing a bunch of jankiness to it. Like this thing, it's not Sublime. what is it? Embed. Like I try to do embed file, autocomplete it, and the at goes away. I think this is like a bug in the LSP extension, and this is like wreaking havoc in my perfect temple of smoothness. He's okay. We have all the buses. Now the question is, we need to make these freaking buses move forward until we meet this stupid condition. So, let's make the buses roll. That's what we need to do. So, while true, we need to make the buses stick. So, var current is a copy of buses, I guess. Does it make sense? Let me think about this. Everything should start at 0. So actually the starting point should be all zeros. And then to each we add their number. But it's not gonna be the first tick that actually meets the condition. So let's start with whatever the values are. And we can say, well, we are at tick 1. It's fine. We skip one thing, it should work. So current is buses. Then how do we implement a tick? I guess it's for current b.star. Can we modify stuff in place, or do we need to make copies? We can modify stuff in place. Am I reading from undefined memory? Let's hope not. Also, what else is wrong? Oh yeah, b star b. Sorry. The current buses. For each bus in the current buses, if b.star is non-null, and we capture it as rev. Holy shit! Wow! How advanced can you get? So this is a for loop over this list. We are and here we are iterating over every element. But since we plan to mutate that element, we grab it with a pointer. Then, and this could be like, this is where you could open a parenthesis and this would be the body of the if. But now we are not putting parentheses, we're not putting curly braces in the body of this for loop. Then we say, well, since these things are optionals, keep in mind I'm taking a pointer to an optional. Since it's an optional, I'm gonna dereference the pointer, and if the optional is there, then I'm gonna do something. And I'm using these as a way of skipping the X elements, the elements that we don't care about. Now, the reason why I haven't just filtered them is because they occupy a slot in the +1 game that the exercise wants me to do. So I'm grabbing, a pointer to the slot. I'm also grabbing the index because that's going to be useful for the checking, not for the mutation. Should I check in place? Maybe I could even check in place. So let's see. So we do this. And what we do is we need to move it forward. So we need to say b.star is rev plus buses I, right? Is wherever, at whatever time we were before, plus buses I. By the way, you know, there has to be a super stupid way there has to be a super stupid way, if you know algebra properly, to find what the thing is without having to like simulate. Kind of like here, I wasn't like simulating, right? I just did the mod thing and boom, got it. I think here there has to be a mathematically quick way of doing this. Like, you know how many, you know how big is the module class of each? Module class of each? It's like a coprimeness thing somehow. The problem is I don't know enough to adventure here without having to open Wikipedia and stay here until tomorrow. So we're gonna be dirty programmers and not like sophisticated mathematicians, and we're gonna do the actual work tick by tick. So the new time is gonna be the new current time is gonna be whatever the previous time was, plus the delta that we need to add. And that's the update. So here's what we can do. Let's test this out. Var I is a SUSY equals 0. I plus equals 1. I minor than 10. Oops. Let's do 10 loops. Please print arrays. Please print arrays correctly without me having to do stuff, please. Hey, Starlinks there. What is Zig? Zig is a general purpose programming language. If you want to learn more, go here. For the full computing time to see if I can auto-generate Zig XCB bindings from their XML spec. Good luck. That sounds like a very funny parsing project. I love XML. Actually, I think that somebody has an XML parser somewhere. I don't know if it's good enough for you, or I don't know. Maybe you do like implementing XML parsers, to each their own, I guess. So in that case, have fun. Line 30. I'm missing a semicolon. Am I? What makes you think that I'm missing a semicolon? I think like these things needs a semicolon, but why? Ooh, wait. Redeclaration of variable I. Oh, you're right. J. Like this is just. You know what? Let's give it this I and let's make this IDX. I don't like pain. The expected type constituent found usize. Oh. Line 16. Oh, you're right, because man. Var str equals it.next dot question mark. I'm dumb. Why did I think that this was fine? Like, oh my god. Okay, invalid operands to binary expression. Usize and optional usize. Oh, we know that this optional is always going to be fine, so we can assert it's going to be there. God damn it, Zig. If current, then current, else -1. Can I do X? Is this gonna work? No, because the types are, oh right. If current pipe C, then C. I need to unwrap. Oh, you know what? Also, why am I using this syntax? Which is horrible. It's current or else X, but I don't think this is gonna work because the types are not working together, right? Expected optional type found 78 use size. Oh shit, right. And current is on top of that, current is an array. Oh god. Okay, so for, oh, you know what? Why am I'm already iterating over everything? Why am I not making use of it? Dummy that I am. So we just print stuff like this, and the args are I think it should be like this. Then everything is on a new line, and the args are IDX and rev. So this is not gonna print the x's. This is just gonna print the keys that have the slots that have an actual number, which I think it's fine. So 29, 58. That sounds right. Then 87, blah blah blah. So we are moving forward. Everything is moving forward. Now the property that we want to check. What is the property that we want to check? The property that we want to check, the magic property what is our magic property? The magic property is that we want to know if, let's go reread, so that we can make sure. What is the earliest timestamp such that all of the listed bus IDs depart at offsets matching their positions in the list? So oh man, so for current so for each current bus, the property is and we need the index. I think maybe we can even test this in line now that I think about it, but I probably won't need this function. So looking at this, it means that we start with the timestamp at which the leftmost bus is, the first bus for us, basically, this guy here. And then we look at this here, and this has to be this same number plus 1, 2, 3, 4, 5, 6, 7, blah, 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 blah. And then the same applies to this. And then the same applies to this, this, and this, and this. And at this point, we should be done. Now, what is the problem here? The problem is that I'm advancing them linearly. And I cannot advance them linearly. Because if I advance them one tick at a time, buses that have higher resolution will always lag behind. I need to level them up like with our like watermark level system, where I take the leftmost bus, whatever time the leftmost bus is, I need to put every other bus above that level. And then, if the property is not matched after that, I need to increase the leftmost bus again and not touch any of the other buses that is above that level. So, this needs to be different. Whoops. And actually, what I just said is almost correct. The actual correct thing is that I need this water level thing has to happen not just with respect to the first bus, but has to happen for every bus to respect to the bus at their left, except for the first one. My God. And at that point, we will be able to find the magic property. So this is already wrong. I mean, it was a useful prototype. It got me closer to the solution, but this is not correct. So let's switch back to the loop forever thing. And here's what we want to do. We need a threshold. So var thresh. Is there two H? Is it threshold? Is it like this? Is it spelled like this? Yeah, it's spelled like this. Threshold. What a weird word. Anyway, threshold. Threshold is current /0. Actually, no, this is base. Let me think about this. Yeah, for a loop, this is the base that we start at. Then threshold is base plus the index. That's... Oh, I'm missing an H in the beginning. Thank you. Wait. No. Is it? Oh God, now you're confusing me. God damn it. I'm gonna have to check that. Okay, no, there is an H. Thank you. Threshold is base plus... Is it base plus index? I'm having trouble with the It's not really that. It's not base plus index. Well, no, actually, oh God, let me think. Is this gonna work if we do this? I think this is gonna work even if we do it like this. Whatever the left is, because that's where we need to be at. So this is the base. This is the threshold where we have to be. Well, actually, this is not just the threshold, right? This is more important than threshold. This is actually, let's call it the target. Because that's what we are trying to get at. And I'm calling it, I'm refining the idea from threshold to target because I think I can do the check-in line. So the idea is, this is the target. And I move forward. And now the next question is, did I hit the target? Or am I below or am I above? So target is this, and then here's what it'll do. While var, let's, instead of dereferencing stuff all over the place, let's simplify stuff like this. New starts at prev, while new is lower than target. We say that we increase new. Well, I guess we can do new plus equals. So yeah, new plus equals. And then at the end, we write new in B. Okay, so while new is lower than target, we keep increasing it until we reach the point. Now the question is here, did we reach the target or did we overshoot it? If we overshoot it, it means that this loop is not the final loop. So if new equals target, or actually if new is different than target, then we say I don't know, met criteria equals false. Yeah, let's put it in parentheses. I think I prefer that. And at the start, we assume that var met criteria is true. Every time for each of these, we keep increasing it until we meet the target. And meet criteria should be always fine for the first element, because first element starts at base itself plus 0. Oh wait, does this always? I think this is gonna cause the first element to never move. How do we force the first element to move forward? I think we need to force the move element to move forward manually. Like here, when we get base, we need to make base up by 1. We force it to be above, which will always make these meet the criteria. We'll do one tick. It will while ends it. The first lot always meets the criteria because it's itself. It's easy. Then we go to the next one. To the next one, but base has to change. Or we can change this. Like, I think this should be in here at this point. Current 0 plus bus is 0 plus EDX. Let me think about this. Maybe not. Yeah, because it's at the start of every loop, so this is always gonna be fine. I think we might be in a good position. So then if met criteria is true, then we break. And when we break, what do? Should print current. I wish I didn't delete the printing code from earlier. God damn it. Print. Is this it? Will the final answer make sense? So let me take a look at the end of code here. It's easy, right? Because it's 1, 2, 3, and 4, 5. So if this is call using iPhone, what? Yeah, it should be easy to check if the answer is at least well formed. Maybe not correct, but at least well formed. Okay, expected function variable declaration after pub. Magic property is not needed anymore because we're checking for the magic property inline now. Invalid operands in usize blah blah blah. Yeah, passes 0 is present. We know that, and also current 0 is present. We know that. It's my input. And I think every input is probably the same, but hey. Too few arguments. You are right, because I need also the index. Oh yes, there's also the second problem. If I mess up, there are good chances that this is never gonna block. That this is going to loop forever. So, whoops, I think we need a debug printing also here somehow. Maybe. So there's a bunch of nulls. So this is 52577, 52614. So it's above. This is also above. This is also above. This is also above. I recommend you start with the temple ones. You know what, Coldmonk? You might be totally right. This is definitely a great idea, actually. Yes, this is a great idea. We are not strong enough to take on the original input right away. Oh god, copy. We are weak and we need help. And now this is what? 1, 2, 3, 4, 5, 6, 7, 8. 8 buses, so just 8. So here we are already at 2, 2, 2, 2. While the answer is definitely earlier and we skipped it. We missed it. Hey Matt, hello. Wait, no, wait. No. The answer was at past 1 million. Wait. The Twitch chat client is kind of dead in the water for now, Matt. You know, it might be that we just have to wait. Oh yeah, look, I got it. We just had to wait. It's just past 1 million. So I actually got the algorithm right, I think. It's just a matter of waiting, I guess. We finally got to a point where performance matters, and now I'm being penalized because I don't know the fast way of doing this. That's nice. That's really nice. That's really, really, really nice. So I think we can assume that I got it right. And we can just print the number that we're at. There's also the idea that I think I'm starting to piece things together. Phew. We got a hint from the exercise that says that the timestamp will be for sure larger than this pretty beefy number. So let's set this at the initial threshold somehow. We can say the base is std math dot, oh god, fuck std math. No, wait, no, it's not so complicated. It's not sort. Okay. std math dot, we want the maximum number between, so how does max work? Do have max, right? Yes. Max between this pretty chunky boy number here and this one other chunky boy number here. And that gives us a pretty nice starting point where it should speed up things, hopefully. Maybe not. Should it? What is the right way of initializing? No, actually, you know what? Okay, so maybe this is a part of the good solution. A better version of this would be to do what we were doing here. And say, can we find the modulo between this and the modulo between this and the value of the bus, the result, like if we know the reminder, we just add the reminder to this and we are done. That's actually a great idea. So base is always going to be current 0, but let's be better at initializing current 0. Let's be better. So current 0, here's what I'm going to do. For each current, and I need also the index. How do we initialize those? We say b.star is super number plus mod of super number b.star question mark. And this if b dot star pipe, I don't know, x. I guess I can capture it as x and use x here. So let me try this again. For each element here, we set it to the super number plus the remainder. And this should work. Let me think, should we do it plus the remainder or minus the remainder? I think we should do minus actually. But not minus the remainder, we should do it minus. So 6 modulo 5 remainder 1. Oh, let's not do 6 because this is gigantic. So let's say 12. 12 modulo 5 remainder 2. I could set everything to, wait, remainder 2, which would put which puts me at 10. That is correct. I think that is correct. 17 modulo 5 should be remainder 3. Can we double check this? Python 17 modulo 5. Yeah, remainder 2. We subtract and we are right. Okay. So this should allow me to cheat, I think, the long wait. If he compiles. Oh yeah, it needs a semicolon. It made me cheat everything, and this is my answer. Maybe. Maybe not. That's not the right answer. No. It seems so right. It felt so right. What did I do wrong? And this is all because I just don't want to wait. Why am I complicating the math just because I don't want to wait? Oh no. No, 071 already released. Oh shit. I didn't follow that initialization. Okay, so let me try to go over it again. I want, so I could do the loop forever and wait, but this is telling me that we know that surely the actual earliest timestamp will be larger than this pretty big number. So what I'm doing is, before doing the main, like, real loop, I'm pushing forward every single one of the slots. I'm pushing it forward. You know what? Let me also do this, just out of curiosity. I'm pushing it close to this number. And I actually want to push it not at where this number is, but one before, basically. So the idea is, let's say that this number, instead of being this big, is, the example that I was making is, this number is 13, for example. So we want to get close to 13, but right before. And the first bus has ID 5. So 5, so I do 13 modulo 5, should give me 3. So I subtract from 13 3 and obtain 10, and I set everything to 10, so that then, but why subtract the mod? Because by subtracting the mod, I get to the first one before, no? Oh my god, you are right. I forgot to update this. Holy shit. Thank you, Flanderer. And my array needs to be 78 now. That explains a few things. I should probably remove these prints. They're taking a lot of time. Also, you know what? Okay, it's time. It's fucking time. Remove the prints. Commander, remove the prints. Enable release fast mode. Well, let's do release safe. Dash D. Oh no, I think that this is different. What is it? It's D release safe. Commander, enable optimizations. So in the meantime, CodeMonk, why do you think what doesn't sound right for you when about subtracting the modulus? Let's see if I'm missing something. Yeah, still on the example. Yeah, right. Comes down to build challenge. The kernel source has magnified to handle the ABI challenge for you, so we just need a way to figure out what the kernel expects. The other issue is that Bitfizz sometimes need. Okay. Oh, Ronaldo pointed it out. Sorry. Are you running on your report or the example? Yeah, right. Oh, god damn it. I missed also the message. Oh no. I did that differently. I'm thinking of it. Maybe you have it right. Well, I think I don't really, because this is taking kind of too long. I can't tell for sure, but it really seems it's taking too long. Goddamn halting problem, right? I'm starting to think that this problem might be a problem where looping is not good and you kind of need to find the mathematics solution to this. Like, what I'm thinking is that each of these things has a set of reminders that it can give you. And what you want is the common reminder. Yeah, but reminder to what? Well, no, the reminder is to the number itself, right? So, like, if a bus has ID 5, the only reminders that it can give you are, well, 0, 1, 2, 3, and 4. You have reminders 0 through 4. Another bus that has reminders that go from, that has ID, I don't know, let's say 7. Oh, let's say 6. 5 and 6. Oh, you did it as buses I times. Yeah, that works too, because you're doing integer division. Yeah, that's probably a less convoluted way of expressing the same thing. I think they are equivalent, honestly. But yeah, that works too. I think we are looping forever. I don't think we're finding answers. You know, it might really just be that the algorithm is right, but it's just too slow. So here's the mathy idea. A bus with ID 5 can produce 0, 1, 2, 3, and 4. A bus with ID, let's say 7, so that it's not too weird, can do 0, 1, 1, 2, 3, 4, 5, 6. But let's say that these are into, let's say that there is a x, there are two x's between, right? So this is a list, 5, x, x, 7. What this kind of means is that the first two are not good anymore, I think. But then I'm missing another piece of relationship between these two numbers. Also, I chose two prime numbers, which is a problem. I think that choosing prime numbers is wrong because this stuff also works on factorizing these big numbers here, I think. Although these all look ugly. 17, 41, 383, 29. Are they all prime numbers? $29, 13, 19. Oh god, they're all coprime. Not just coprimes, they're all primes. 23, 37, 631. Give me 631. What? No. 631, 41 and 17. 41 and 17. They're all prime numbers. And this means that there is a freaking way of doing this analytically. God damn it. My answer to this problem was very, very big. Yeah. It's a multiplication thing. God. Time for math. I don't think my brain is big enough, especially not right now. Probably never. We need to talk about async. How are we going to do this over the CABI? Matt, you don't. The answer is that you need to play tricks. And understanding what playing tricks means requires you to get full understanding of what async normally does. But to get past the CABI, like you cannot get past the CABI with async await. What you need to do is either black box the computation or do what I think Andrew defined it as a seam, which I think it's probably a common term for defining this process. But you need to find a way of synchronizing with the async stuff without using the async primitives. And that's what you've seen happen with main. Main, at the end of the day, well, I guess the start symbol has to be CABI. And to connect the CABI with your async main that you have in Zig, the trick there was to have that thread run the event loop until the event loop completes, at which point, if the event loop completed, you know that the main frame has also completed execution. So let's try to reason these on the small example, right? Where is it? Here. Oh no, did I leave the advent of code for this? Yeah, I did. Look at also these numbers. I bet they're all prime. Yeah, they all look prime. So look, we also got more examples. 17, 13, 19 is 34, 17. So I think that this is really a function based of their relative reminders. It's probably like 17, the reminder between 17 and 13 multiplied by 17 plus the reminder between 17 and 13 multiplied by something else. I don't know. It's probably something like this. You know what? Let's be stupid and try this stuff manually. While this is thinking, let's try to be funny about it. Python is something like 17 modulo 13 is 4. 13 modulo 17, it's 13. Of course. I don't know, so maybe it's like 19 modulo. But then there's also this stupid empty slot that you need to factor in. God damn it. There's also the empty slot that you need to factor in. $34, 17. Oh, you know what? 34, 17 divided by 17 should give 0. No, sorry, modulo 17 should give 0. Modulo 13 should give 2. Let me think, why is this not the case? Why is it giving 11? Well, it is, you see that it's minus 2, I guess, okay. And in 19 it should give minus 3, which is then 16. Sorry, 19 should give 16. It gives 16. So this is the relationship. But wait, we're not really there. We have a piece of the puzzle. We are missing the second part. Yeah, clearly this has to be the case. But then, let's say that we know this. How do we get to the other side? Wait, we know what's the inverse operation of reminder? Like if I have 19 and 16, how do I get to this? It's 19 times x plus 16, I guess. Right? So if this is x, we know what this number is. We know what the reminder has to be. And I think that if you combine all these constraints, you can get to one precise number. I need to do math. God, please complete stupid math. Okay, let's think again. You know what another solution is? Spend like $50 on some stupid GPU instance on some cloud and have it work there super fast. Oh God. So we know this. What else can we do? I think that's it. I think we know. I think that's it. Multi-threading, that's always a performance win, right? True. You know, I think I know how to do it. In the mathy way. Maybe it's not the best perfect way, but it should be hopefully good enough. function math. So here's the idea. We do the parsing, whatever. Okay, we parsed. Then here's what we need to do. Var base is passes 0. And then for well, no, it's not like this. It's still a while true, I think. But for well, you know what? Let's do it without while I, or do we? No, I want to do it with a for buses if for buses b if b pipe bus, I don't know. I need to unwrap the optional. We have the index, so we grab the bus, and what we want is so we start base like this. At the end of each loop, we multiply base by one more, so we add base to itself again. So base plus equals base. And for each one of those, what we want is and I also want to give a label to this while. Or do we? No, I don't think I can. So for each one of these buses, we want I'll get there, I swear. We want the modulo between base and the bus to be equal to what? To the index. And if it's different, oh, here's what we can do. If it's different, we break. Else, print found. Base. I think that might be it. Or maybe not. Maybe that's not it, and this seems to be faster, but maybe this has the same problem. Also, I don't want mod, I think I want rem. And this needs to be bus minus IDX. Mighty Space Dragon, thank you for the follow. Is this it? This should be much faster than this, but by far. So let me check again. We keep looping on the buses. And for each, also this unwrapping thing I could probably make do without in terms of efficiency, but you know what? Anyway, maybe we should make an array list. Okay, let's do it well. Since let's go full math. So instead of doing this under optional shenanigans, let's make two arrays. One with the numbers, one with the indices. So buses stop being these, or you know what? Let's do what do we want to do. Here's what we want to do. We want to do let's say we want to call this temp actually. Let's make it, yeah, let's do things nicely for once. So this is our temp variable. This stuff can go inside a block. Outside, what we want to survive is what? Two slices. Var buses, well, let's say times and var bus IDs. Well, let's just call it IDs. No, it's not the IDs. Well, it's times and like indexes. So we have temp. And actually we can do this too. For each of those, var present usize equals 0. I should probably use an array list for this stuff. Would have been easier. Should I use an array list? Yeah, you know what? Let's do this array list thing. Let's. Okay, sorry. I need to refocus. One moment of refactoring, and then we can be back in business. So the array list basically allows me to do this stuff more easily at the price of needing to have an allocator. So var arena is std heap arena allocator dot init on std heap page allocator. Then var deferred the arena dot the init. Yes. Then var I don't know, temp is an std array list. The type is usize. How many of those do we want? We want 2 of those. Temp. Well, it's not really temp actually. At the end of the day, it's like times r and indexes r, or actually r times, so that they don't pollute my autocomplete stuff if I start typing times. Okay, we have 2 array lists, not init arena.allocator. Do the same below. We have these two things which take place of those slices. Finally, we want then what? There is no temp anymore. There's no present anymore. it.next. So while it.next, we have b. If it's b is equal, well, you know what? If b is different than x, then we do r times dot append this item, and r indexes dot append what? We need an index that I think we cannot get from while. Can while gives us an index? That would be nice. If it does, nice. If it doesn't, that's fine too. Oh no, it doesn't, because that's we are actually, so this, we are unpacking an optional, so we need to do this, I guess. Var I Susie equals 0, and then I plus equals 1. And here we append, actually we plus equals 1 if we are successful. We append what? We append I to indexes. Woo. Okay, best streamer on Twitch. Yeah. Almost. Although I'm not really, actually, because I can't solve this stupid thing. You know what? Now I don't want this to complete. I want this to loop forever, and I want to solve it the other way. So now I'm getting the times and the indexes correctly. Now, as we were saying, now we do const buses equals r times dot items, and const indexes equals r indexes dot item. So this gives me slices, and we finally got to a freaking slice. Now, what do we do with those slices? We have buses 0, which is the time, which is going to be our base time. Every single loop here, we increase it by 1. Well, we multiply it by 1 more. We add it to itself. And then for each of the buses, which we could skip the bus 0 itself. You know what? Should we? No, we shouldn't. Well, we could, but whatever. Let's leave it there. So for each bus now, there is no if bus bullshit. So let's call it bus now. For each bus, if the remainder of the base with the bus of the base with the bus, if the remainder with this base of bus is different than bus minus the remainder, has to be, what we are searching for is when everybody is equal to, yeah, the bus minus itself, because we had 16, which was 19 minus 3, which was its index. If we find one that fails this check, we break, and then we do another piece of the for loop. No, well, we bait from the for loop, and we do another loop of the while. But if we complete the for loop and none of those, and basically all of them match this rule because all of them are equal, then we print found. And we break outer. And we concluded. But we could actually break outer and like print base after. Base. Do it here, do it here. So this seems much more efficient than before. Is this really it? Is there a better way to do this? Maybe? Maybe? Oh, right. I mean, should I kill this one or should I let it go? This is way too long. Also, wait. Am I running math? I need math. Okay. Error. User identifier current string. Oh yeah, I named it to B and then I forgot to change it. B. And here's what we can do. Print. Just print the base and then on a new line. And let's see where we're at. Also, I can repeat the same trick for the base. We can say base doesn't actually start there, but base starts at 1000 minus passes 0. Error is ignored. Oh, I need tries. Try. Yeah. Okay, whoa. Okay, so this is going super fast. Nice. Integer overflow. Bad. But hey, at least we got woof at the speed of light. Is this really usize overflowing? Also, is this number correctly? Is this number correctly this? Oh, Python. Indentation error. Okay. So we initialize. This is a gigantic improvement. So we initialize the thing correctly. And we immediately overflow. Okay. We immediately overflow. So what is the next trick up our sleeves? I don't know. What is the next trick up our sleeves? What is the next trick up our sleeves? Bigger numbers, U128, maybe. But are we really? So there are two options here. One is, this is actually where we need to be. No, wait. I think there's something wrong. Oh, you know what? I'm a moron. I'm adding base to base, but I don't need to like double it every single time. I need to add the step bus is 0. So, so now I'm gonna step normally. Okay. And I don't know, is this fast enough? It's still searching a lot. Also, maybe quick consistency check. Is this gonna work with this? If we do the non-weird initialization. Not really. Not working. Is it because I'm not using mod? No. I'm messing up the relationship. Okay. I fucked up the relationship. But we are there. We're almost there. I can sense it, we're almost there. So, God, it's 5 hours and a half. Oh, so let's revisit this thing. The number, whatever it is, has to be a multiple of 7, has to have remainder 1 from 13. We could probably speed up a lot. Like, we also know a lot of things there, but we could use the knowledge of how much reminder each one of the other one has to know how much. Well, anyway. So we were saying that we know that whatever this number is, and we were looking at it from the other end, right? We were looking at it from, we know that this is the number. We know that this modulo 17 is a 0, which is fine. Modulo 13 is index 0, 1, 2. And it gives us 11, which is 13 minus AD. Oh God, 13 minus AD equals the remainder. 13 minus AD equals... Yeah, remainder. Number. Okay, you know what? Let's do this. Copy. What I want is now to, I want this. Actually, no, let's leave them. So I want the index and I want the reminder printed. Okay. This should be fine. And maybe we can also do if base greater than, I don't know, 500, then break. Oh God, what are all these zeros? Oh, okay, this base is pass. Why do I have all these zeros? Because I'm a moron. Wait a second. I'm a moron. Okay. I'm a moron, but there's something fishy happening here. Base is 17. I want the index. Why is the index always 0? What? Why is it? Because it says 221 and 17 never matches. That doesn't make sense. 17, what are you talking about? 17 matches perfectly. What? Is this a parent? Okay, this should not be it, but I'm definitely... Okay, my thing is definitely busted because it should always go past the first loop. So what's happening here? Can we print also buses.len? Am I parsing this stuff wrong? And let's make these like, I don't know, 50. Three. That is indeed correct. 3 buses. So why are we not passing? Why are we not passing check? Because I'm a moron. It's not break. It's continue or it's nothing. Right? No. It is break. Like if we find one that does, if we find one element that doesn't match the relationship, we leave immediately. The problem is, okay, let's print the equation then. Print. Weird. I know we're printing this already again, but zero different than 17. Am I a moron? Am I a moron? I am a moron. Because for the first one, this is for the first one. Okay, so you know what? If idx is 0, continue. Different than 12, 13 different than 17. Okay, let's not do this break thing anymore. Let's keep going. And it finds 2924. that is not really correct, is it though? It has to be 3417. Why is this like this? So it goes back to, it finds 13, 12, difference 1, 19, 17. Where is the third though? Why doesn't it print? Why? Oh, because it's not printing 0. Okay. So what is the problem here? Oh, right. The problem is EDX. I cannot use EDX directly here. Here, I need to use the indexes array, which is why I got rid of the other thing. I must have it somewhere else too. What did I do? Where did I put it? Oh no, wait. Here it has to be the index. Yes. No. It should be indexes. 1 and 2, but this is wrong because it should be 0, 1. It should be 2 and 3. Why is it not 2 and 3? Because I'm a moron. Because the whole point of this exercise is to increase the counter even if we found X. Okay, so we're back in business. 3417. Okay, so now it finds correctly the right thing. So now, come back to the big thing, big boy. We can start at 10 billions or whatever. Let's comment out all these prints that I think only slow things down. And boom, we integer overflow immediately. Nice. Well, let's print to the base. How is it possible that we integer overflow directly? I think we are integer overflowing in... Where are we integer overflowing? Is it here? Is it in the sum? Is this really close to the upper level of a U64? Okay, so I think I need to employ a second trick here. So since we are immediately reaching the overflow, we need to employ a second trick. And the second trick is we find the common, we multiply all the numbers together, and we know that every time we go past that number, we can subtract it. Everything keeps working. We just need to keep in mind to add it back later. Which is a problem though, because then we can still not add, just do a normal add, it's gonna overflow anyway. What the hell? Why is this overflowing? Also, yeah, why is this overflowing so quickly? Is there a max something? Import math dot max something. No, this is like a gigantic number. There is no way. Or is it? Oh god. Python, why no underscores? Come on. No, there is a lot of space. Where the hell are we overflowing? So this points at RAM. Is this really RAM overflowing? Really? Everything is unsigned. Can I just do percentage? Like base percentage bus? Is this gonna work? Is this any better? We do integer overflow immediately. How? Okay, show me some info. How are we overflowing? We're overflowing because we are overflowing because we are trying to do this number modulo what? This is 13. What's the one after 13? It's 19. How can what? How can this modulo 19 overflow? Hello? What? Okay, so there's something weird happening. So this number here, modulo 19. What? 5. What is going on? The computer seems fine. Also, why is every time that I copy there, something weird happens? Okay, it's just 5. How can this overflow? Integer overflow. What's up with this? How can that be an integer overflow? I don't get it. Where is the integer overflow? Oh, wait. Wait. I say overflow, but it could be an underflow here. Bus minus indexes. Oh, I know what it is. I think I know what it is. It's the reminder being negative, maybe? Like, could be that this produces a negative reminder. So let's do it mod then. Then this should be fine. Although, weird. No, still integer overflowing. Oh, but I was printing here, right? I was printing here the the number bus is 13 and its index is 47. There we go. Here's what's causing it. It's an underflow actually, and the problem is that 13 minus 47 is wrong. So because these also needs to be is it 47 modulo 13? Let me think about it. So yeah, we always need simple stuff. No, I think the number has to, yeah, 47 has to be to reduce modulo 13, and that's when we can do the. So I think we can do it like this then. Oops. Base percentage bus minus indexes blah 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 percentage bus. Okay. Printing is probably murdering the performance, but hey. We're having a lot of trouble though. We should not be searching like this. Like, I don't think that this search is really doing much improvement. There is another thing that we are forgetting. Like, I think that the problem now is that here I'm increasing the step like this, and there are situations where it's clear that this is a bad idea. It's clear that this is a bad idea. So how can we be smarter at moving forward? Instead of moving by buses 0, how much should we move? Oh man. How much should we move? I don't know. So anybody got recommendations? Man, fucking math. Also, you know what? This reminds me. Is this a Chinese theorem rest thing? Yeah, reminder theorem states that if one knows the reminders of the Euclidean division of an integer n by several integers, oh fuck yes, then one can determine uniquely the remainder of the division of n by the product of these integers under the condition that the divisors are pairwise coprime, and ours are all prime, so they are all absolutely coprime. The earliest known statement of this theorem is a long time ago from a guy that was probably much smarter than me. Statement proof existence, please. Is there like a Zig implementation that I can copy paste? I can't copy paste LaTeX. God damn it. Let n 1 through k be integers equal greater than 1. CodeMonk, I think like micro optimizations are not LaTeX to the compiler. Yeah. I don't think micro optimizations are gonna save your ass with this thing. Like, this thing is evil. and it's meant to stress whether you know the algorithmic, like the metric or not. Like, look at this. Even if I could, even if I cut the prints, it's still way too much. So the Chinese remainder theorem asserts that if the n blah 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 pairwise coprimes and a are integers such that a is between 0 and n for every I, then there is only one integer x such that x is between 0 and n, and the remainder of the Euclidean division of x by n11 is a11 for every I. This may be restated as follows in terms of congruencies. If n I are pairwise coprime and I are any integers, then there exists integers such x that blah 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 defines a ring isomorphism. Uniqueness, existence, case of two moduli, existence, direct construction, computation. Systematic search. It's easy to check whether a value x for the solution. It suffices to compute the remainder of the Euclidean division of x by each n j. Thus, to find the solution, it suffices to check successively the integers from 0 to n until finding a solution. Although very simple, this method is very inefficient. For a simple example considered here, 40 integers, including 0, have to be checked for finding the solution, which is 39. It's an exponential time algorithm, and the size of the input, blah, 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 blah. For this method is rarely used, and neither for unwritten computation nor on computers. Search by sieving. The search of the solution might be made dramatically faster by sieving. For this method, we suppose, without loss of generality, that blah, blah, blah. If this were not the case, it would suffice to replace I with a remainder. But look at that. This implies that the solution belongs to the arithmetic progression a1 plus n1 a1 plus 2 n1 what? By testing this value in this numbers modulo and 2, one eventually find a solution x2 of the two first congruencies, then the solution belongs to the... Oh my god, let me read chat before Wikipedia finally kills me definitely. So let's see what people are saying. Multi-threading. Bigger numbers. Yeah, my fucked up relationships, holy shit. Looking at Zig coming from C++, I don't think I will be switching to Zig as a main language anytime soon. But I very much like the idea of it. Yeah. I mainly like the expressiveness of C++. I'm personally quite comfortable with it, so having the ability to find control while also being able to use pretty level abstractions is valuable to me. Oh yeah. Yep. Please, somebody help me with this stupid algorithm. Okay, here's what we can do. Python Chinese reminder. Please give me the code, for God's sake, so we can move on with our lives. Oh, C version. Ugly as fuck. Cheating. AOC police incoming. What do you mean? It's not cheating. Is it cheating? It's not cheating. I'm not using an external library. Actually. I am cheating and I am using an external library. And you can't stop me. New file. Save Chinese reminder theorem dot c. You can't stop me. So these ints have to become long longs, I guess. I'll fix this later. You're trying to stop me with blue screens, but do you have enough points to do that? I'm inevitable. I'm like Thanos. Const C equals C import. No wait, it's import. No, it's C include. No, I'm dumb. It's C import. Oh, if only. If only. And this should be. This should be it, right? Oh god, I don't remember anymore what is what. Time for translating bugs. We'll see. We'll see. We will see. You know what? Worst case, I'm gonna compile this fucking C thing in as an object file, and I'm gonna link to it. I'm unstoppable. You can't prevent me from doing this. So yeah, it's C import, C include. Oh, we don't even need these parentheses. Okay. Right, because we are not doing much. You can't stop me. You can't stop me. Now we need to learn how to use this thing. Oh god. NA. These are the numbers, and these are the reminders. Right, so we have that. Why am I doing all this mess? So we have all of these, I think. Up function. Hehe. Bar const stress is C dot called Chinese reminder of what? Oh, I need this part here, I guess. And I need something else. No, I don't. Okay. The res is Chinese reminder of bus of pointer to buses, pointer to indexes, and buses.len. Print. Is this gonna work? Enough math? It's time to try C. Oh god, please stop. I feel so sad. I think I need to also specify, yeah, C import failed. So it's, oh god, dash D C zig build exe help. When I can report Crimes against iguanas. Oh, let's see what people are saying. Unfollow. Yeah. Not a pure Zig solution. Sniff. I know. I know. I don't want to type all that math out myself. I'm going to introduce bugs for no reason. Let me just link to this shit and get done. I paid enough price for this. MCPU model, name, package begin, package end, compile option. No, it's no, it is a compile option. Where's my import stuff? Please, iSystem. Add directory to system include search path. Dear, add directory to include search path. Yes, it's I. So how do we pass the flags like this? It's like di equals dot. No. Invalid option di. Okay, Zig build Zig run source slash day 13.zig dash I equals source slash. Let's see if this works. Import failed. Include crt.c. Why? What am I getting wrong? You're supposed to suffer. That's what IUC is all about. Any help? Why am I messing? Why am I having this much trouble importing this stupid C file? What am I missing? Sound.io, blah blah blah. But this is an example that doesn't even compile. Well, it isn't even compiled. CRT.c not file not found. Should it be dot? I don't know. Am I using the right thing? Zig run help. Using the right option? I, right? Uppercase I dear. Add directly to include search path. Angle brackets looks in include path. Don't do equal. Are you really telling me that the problem is the freaking equal? Oh god, yeah, that's it. Expected type C pointer to C int found constant pointer to usize. Here we go. So var now the C compatibility dance starts. So this should be one problem solved. Second problem is a pointer. I hope this cast works. The problem is I have a bunch of usizes and not C ints, and we can make this work. What's it called? Long int. Does it have? It has spaces. Oh my god, is this really it? Oh god. Oh god. Wait, no, these are pointers. No, that's right. C long usize. Oh, come on. Okay, fine. We are C long in the Zig code. I don't see any problem with that. Everything is a C long. Expected type, pointer to C long, found pointer to slice. Expected type C long, found usize. More than an integer overflow. God damn it. Where? Wait. What? Integer overflow where? Matt Knight is recommending you 128. Wait, no, long ints are 64 bits, right? Or whatever, long int size, size, please. Yeah, see data type. Long sign, unsigned integer type. Yeah, long int. I mean, this seems still big enough, honestly. So this should be fine. Usize were overflowing too, right? You think it's this cast that it's overflowing? No, well, it doesn't make any sense. You shouldn't need more than 64 bits to solve this. Yeah, I believe so. So why are we overflowing? Where are we overflowing? The problem is, for people that don't know, the stack traces are busted on Apple Silicon, and so I can't trust them. What I can trust, though, is parsed. Can I print parsed? Okay, so we get an integer overflow really in the C code. Why do we get an integer overflow in the C code? Where? You know what? Maybe that's what they want. Maybe they're using that semantic knowingly. So let's embrace this. Optimization release fast. Parsed. Answer garbage. Okay, not good. Not good. The answer is kind of garbage. Why is the answer garbage? Why is the C code so bad? Why can't you ever trust C code and you always get garbage back? Because it overflowed, obviously. But why is it overflowing? These are all 64-bit integers, right? They should not overflow. Remove the sign and submit. I mean, yeah. But how? I don't get it. How can they really, like, if they really overflow, it means that we don't, 64 bits are not enough, which is super weird. Because this number is big, but it's not that big. This is probably a bad idea. I don't think that there is... actually, was anything unsigned? No, and nothing was unsigned. Is there any temporary thing that... No. Okay, let's make things unsigned. This is clearly a bad idea. But hey, I don't know. Do we trust this? It was super fast, by the way. Let's see. So here's what we should do. We should print. We should print buses and indices. So for let's do buses. It's easier. For buses, we get pipe B, pipe I. Well, and then we do print. Oh, come on. Silong does not support field access. Oh, it's a comma. Okay. Except type blah 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 found something else. Why did this? What? Yeah, but why did this work? Why this run and give this answer earlier then? Yeah, out of curiosity, let's comment this. Let's run the code. So here's the number. You know what? I'm thinking that this is complete garbage. But anyway, modulo 29. Okay, it's already busted. Wait, no. I'm dumb. I'm kind of dumb. Why? I inverted them. Indexes. Yeah, I inverted them, but it's still wrong. So the first number is giving. It should be it should be 29 and give reminder 0, and it gives reminder 10. So no, that's wrong. What about the negative one? Is the negative one magic? Well, I mean, negative, positive should be the same, no? As Komari was saying. So modulo 29, 4. That's already not good. Out of curiosity. Negative 1, 25. Definitely not there either. So yeah, let's make these unsigned, I guess. So let's find and replace all C long to CU long. Place all. Oops. It still overflows though. No, division by 0. You know what? I think that the why division by 0? I think the people on Rosetta Stone are not doing a good job. Yeah, they're definitely not doing a good job at implementing this algorithm. Kind of disappointed, Rosetta Stone. Why is this so broken? I don't get it. Oh, when n are not pairwise coprime, the program crashes due to division by 0, which is one way to convey error. Wait. Did I swap the two arguments around? No. It's passes and indexes. N are 100% coprime. Like, these are all prime numbers, right? Did you check all of them? I don't know about 383 and 631. Ma io try to compare questi percentage instead. No, not touching that. Okay, let's go back to prime list. So 2937, I think we saw them, yes. 631. There we go. 13, yes. 19, yes. 23, yes. Right? Yes. 383. Yes. 41 and 17. Come on, yes. 41, 17. So, no, they're all... What is this library smoking? In any case, this flip from... So this flip to unsigned is a bad idea. But I don't get it. Why is this not working? Why is this such a problem? N is the first argument, yes. And these are the prime numbers, and these are the A's. Oh, wait. I know what the problem is. It's my fault. The A's need to be made modulo to like this. Like this. We append I modulo. We need this. Const bus equals this. We append the bus, but here we also do I modulo bus. And this should be better. Reminder the video is still on long linear floats must use RAM or mod. God damn, it's still giving me that super negative number. But why? Why is it giving me this super negative number, which is also wrong? Yeah, 29 is it's giving me 23, and it should give me 0. Come on. And also we should avoid release fast so that we can get proper errors and yeah, integer overflow. So annoying. I want to see this work. Okay, you know what? Give me a Python version. It's time. Do we have a Zig version by any chance in here? No. Okay. Python, let's go. Procedural, Python 3, functional. Zip with either, uncarry, quoted, partition either's, numeric product, either, carry. What is this? Oh god, no. You know, this is fine. Ah. Okay. I don't know. I feel so dirty. But hey, this is like survival. I must survive. Python. Python, come to me. I need your help. Also, which version do I have? Oh no. Exit. Python 3. Yes. Yeah, we're coding Python. I'm sorry. Things are going south very quickly. Source. Is this really... Why is it so hard just to get this answer? So, why is it so hard? 29? Yes, that's 0. Why is it so hard for C to work properly? Why is nobody coding it correctly? So, wait. Then we have 37 has to give 23. 23. So this is the correct answer. There we go. We found it in a super simple Python script. Stupid Chinese theorem. Why is the C version busted? Why is nobody complaining that the C version is completely busted? Oh, you know what I should have done maybe? Consider if 32 bits were enough. Maybe 32 bits were enough and I even didn't need to go to change everything to long. Okay, let's try this. Undo the long thing. And this stuff is just cint now. If that's the case, I called it on myself. Like I was the cause of my own demise. Why does it give division by 0 if the numbers are all prime? What is going on? What is wrong with this thing? Did they really swap around N and A in the implementation? Maybe it's them and not me. No, it gives division by 0 anyway. Would it be faster to translate the algorithm to Z? You think so? I mean, maybe. I mean, looking at the Python version doesn't seem too bad, but like the C version looked kind of crappy. Look at this, all this stuff. Oh, Python is also abusing this thing. God damn it. I'm doing const buses equals list.items and then passing abuters. That's wrong, right? I'm not doing const. Where do you see const? It's var. It was const originally, yes, but I changed it right away. Like the type system told me that I was passing a const pointer to something I didn't want the thing to be const. It doesn't matter, you're passing a pointer to the slice, not to the data. Fuck. You might be right. Because it's a slice, you're right. I was so comfy using arrays until recently. You might be right. Is it? Oh god, is this it? Kinda integer overflow. Okay. Is this something that we can solve with long-longing stuff? This explains also why the pointer would not coerce. You are absolutely right, and I'm a moron. And I'm a moron. But we still get integer overflows, I think. Yep, apparently. Why? God only knows. But yeah, I was passing a wrong thing. Now I'm passing the right thing. You're using Cint in Zig. Well, long in C. All right. Yep, I need to update both. Place. C long. Replace all. C. Oh. So I did need to do the long update. Hi, Sebastian Keller. I did need to do that. Yes, I was passing the pointer of the slice. Oh god. This wasn't the case until this thing, because I was playing around earlier with arrays themselves, and I forgot that, yeah, if it's a slice, you need to do dot pointer. And yeah, and I guess we got the right answer from C2, which is, oh god, no, it's not the right answer. What happened? That seemed pretty much the right answer. Oh, you know why? I think because this is the... Wait, what? I mean, it's super easy to check if this is the right answer or the wrong answer. Okay, I think my iTerm has pooped itself. Goodbye, iTerm. Force quit. Wait, is this really IRC? Am I reading here, or is this like a... Wait, what? Okay. My iTerm is... The application survived? What? So, a few things got messed up. But my application survived. What the hell? Is iTerm secretly Timuxing me around? What's going on? Anyway, okay, can we do the forbidden practice of placing two windows? Can we try? No, maybe. Split pane vertically. Okay, we're saying the Okay, we release. I think we lost also our history. Okay, day13 dash I source slash. Oh, I'm dumb. It's a run. Okay. So this is the answer. Okay. So with Python 3, the warning scares me. So this is the number that we got. Modulo 29, 0. Modulo 37, 23. Modulo. Oh, you know what? I see the problem, I think. Modulo 20, sorry, modulo 631, 29. You know what the problem is? I made this change here where where apparently this seems to be fine. I think the document was saying that this to be fine, but I think this can change the answer maybe. Let's see. No, it produces the same exact answer. Is also Python agreeing on this? Yeah, Python is agreeing. Well, Python is still using the other array thing. That's crazy. You want the answer modulo 37 to be 14, not 23, I think. Oh god. No, it's 33. It's 23. Why do you say 14? The idea is, this is the first bus and it departs whenever it departs. But then the bus right after, the bus with ID 1. Oh, you know what? Wait, this is the number. Does it need to be multiplied by anything? What is the real-time stamp such that all of the listed bus IDs depart at offset matching their position in the list? Unless the answer is something like it's close to this one, but not exactly this one. But I don't know. Like, I reconstructed everything. So the fact that I want. Oh, let me think about this. I think I understand now what you're saying. Maybe right. Let's see. I understand what you're saying. So this would be bus minus. Although I'm not sure because 29, 29. Well, let's see. This is the parser at ID 0. You're right. I think you're right, Ronaldo. Yeah, it's the formulation that was like this. Boom. There we go. There's the right answer. Yes, the formulation was inverted in my code. Yeah. Woo! Way too stressful. Way too stressful. Oh my god, it took forever to get this gold star. Honestly, you know what? I would have tried another way to get money. I don't know, selling something else. Not than trying to solve this freaking problem. Holy shit. I don't know what to say. Like, what did we learn today? don't pass around pointers to slices when you think you are passing the pointer that the slice contains. In my defense, I will say that up until this exercise here, I always dealt with straight up with arrays. And so I could just take the array of the thing and it was fine because the thing was an array. But if you have a slice, the pointer to the underlying data is in dot pointer. It's not pointer of the slice. Because the slice is like it's like taking a pointer to a pointer. Now, why did this thing not warn me? It actually did warn me. It told me that the pointers were incompatible, but I was thinking, but I didn't read the error message too attentively, right? Because I was like 5 hours into this into this thing. And so I ignored the warning and I went through and I used pointer cast. The problem with pointer cast is that it's it's like heavy duty machinery. It like obliterates all the original type. And if you use it, you have to know what you're doing. And I didn't know what I was doing. So we learned this. Second thing that we learned is that long int is what you need. I am actually surprised that this Advent of Code exercise requires you to use 64-bit data types. That's surprising. I mean, it's not like people are gonna be locked out of this answer, because even if you have a 32-bit machine, I think you have this. You have always access somehow to a 64-bit integer. And what else? The Chinese rest theorem is annoying. Sorry, I keep calling rest because in Italian remainder is rest. So that's why the Chinese remainder theorem is interesting and annoying, and the algorithm, I don't know it. I don't want to know it. I mean, I know the general idea, and I should have smelled it earlier that this is what we needed to do. It took me a while to get there, but hey, at the end of the day, I did get there kinda by cheating because I then copied this thing. But hey, next thing that we learn is that if you want to interoperate with C, boom, there you go. C import the thing, pass the right path to run or build exe, or I think you can do this also with the build system. Like, I don't remember, build day 13. I think this should work because you can pass down stuff. Oh man, the target equals derelease, project specific options, general options, prefix, verbose, search. Oh, there we go. Search prefix. Is this it? Probably not. Okay, no, it's not search prefix. So maybe this option is not wired in the build system or in this particular build script. I'm wondering why is it not something that you can specify normally, but although it kind of makes sense, I guess. I don't know. In any case, if you're doing just run or build exe normally, you just pass in the path where you put your C file, and boom, it got imported. Also, people were complaining that I should use Zig code, and I'm starting to kind of agree. So here's what I'm gonna do: Zig translate C /ctr.c into ctr.zig. Panic during panicking. Oh god, no! What's happening? I think Command Control Q kills this tab. This panel? No, Command Q. No, it's Command W. Yes. So what's happening is really translate C, panicking, attempts to write an error. Oh, file not found. Okay. Oh, because it's crt.c. Okay, whatever. crashteamracing.zig. Oh, come on, refresh. Oh, actually, no, it's in the folder above, right? Is it? There we go. So people were complaining that you should use, oh God. Okay, let's not look at what's down there. You didn't see anything. So let's make it zig. And now, finally, we have a pure zig solution. And I think that we can cast, oh my God, look at these bit casts as, okay. So no more C. People don't say I'm cheating. And then Chinese remainder. Yeah. Let's see. Now I can go back to using my build script, I think. There we go. Pure zig solution. No more C code. I don't see anything wrong with this. This seems perfectly fair to me, honestly, right? No libraries. So what can I say? We are done. Oh man. So I would say Translate C doesn't make the best looking code though. But I could have done this and maybe clean it up a little bit. That would have been nice too. But you know what? Yeah, technically fine, I guess. And technically fine and right is the best kind of fine and right possible, right? Yeah, now it looks good. I agree. So, man, I'm calling it a day here. This was stressful. So YouTube, bye-bye. I'm cutting the recording here.